What if 95% of the universe we inhabit is completely invisible? Across the vastness of space, challenging proofs that matter can vanish in an inexplicable way. Dark matter and dark energy are governing every galaxy. These are not merely empty holes. They are challenging evidence against physical laws. We are governed by unknown entities that serve as the foundational scaffolding for all galaxies. The true mystery is not the search for extraterrestrial life, but the terrifying question of why the overwhelming majority of the cosmos intentionally hides from our sight. We are looking at the ghosts of universal laws we have never been permitted to know, silent warnings etched into the very fabric of space-time. For thousands of years, humanity has looked up at the sky and believed that the shimmering lights above the stars, the galaxies, the glowing clouds of gas were the entirety of the universe. But the truth is far harsher and far more unbelievable. Everything we see, every beam of light in the cosmos, is nothing more than a thin layer of decoration, making up less than 1/6 of the universe. The rest, an immense ocean, accounting for more than 85%, is completely invisible, emitting no light, reflecting nothing, and interacting with nothing except gravity. It surrounds us, flows through us, holds galaxies together, and shapes the structure of the universe itself, yet no one has ever seen it. An unseen force so powerful, it determines the fate of the stars. Science gives this chilling, enigmatic substance a name that sends shivers down the spine: dark matter. What do you think dark matter truly is? Share your thoughts in the comments below. I'm really curious to hear your theory. Although completely invisible, dark matter appears everywhere in the universe, threading through every gap in space and wrapping around galaxies like a structural layer that no human eye can see. Its silent yet overwhelming presence makes it one of the greatest mysteries of modern science. The irony is that we cannot observe it directly. Everything we know comes from the gravitational footprint it leaves behind. When astronomers discovered that galaxies were spinning so fast they should have been torn apart by their own rotational force, they were forced to accept that some unseen substance must be holding them together. In ways that science has yet to explain, dark matter behaves like a colossal framework, weaving gravitational webs around galaxies and determining how they exist, move, and evolve over billions of years. On the scale of the universe, dark matter is not distributed chaotically, but instead links together into enormous filaments stretching hundreds of millions of light years. These strands weave into one another, forming a three-dimensional web that acts like the invisible backbone of the cosmos. In supercomputer simulations, the universe appears like a giant foam structure, with galaxies merely tiny bright points clinging to these shadowy threads. This vast network determines where galaxies are born, how they merge into clusters, and how the immense voids between cosmic structures are shaped. It is a silent framework hidden from sight, yet governing the entire large-scale architecture of the universe we observe today. Even as scientists continually expand the limits of observation, the true nature of dark matter remains buried in an unsettling absolute silence. It emits no light, reflects none, and absorbs none, rendering every telescope powerless against its existence. It barely interacts with normal matter at all, so little that even laboratories built deep underground cannot capture a single particle. Every second, trillions of dark matter particles pass through our bodies without leaving the slightest trace. Without its gravitational influence holding galaxies together, humanity might never have known that such an invisible substance pervades the entire universe. For decades, physicists have proposed bold and ambitious hypotheses to explain the true nature of dark matter, a form of matter that governs the universe, yet has never once been directly observed. One of the most popular candidates is WIMP's heavy particles that interact so weakly they could pass through light years of solid matter without slowing down. Another hypothesis points to Axion's particles so light they are almost massless, yet could exist in unimaginably large quantities, forming a vast ocean of dark matter throughout space. Some scientists suggest sterile neutrinos, ghost-like neutrinos that interact with no force except gravity, rendering them nearly invulnerable to every detection method we possess today. Even more daring is the idea of dark photons, belonging to a parallel dark sector where unknown particles and forces operate beyond the reach of modern physics. Although each hypothesis opens a fascinating path forward, none have been confirmed, leaving the mystery of dark matter deeper, more challenging, and more elusive than ever. All these theories remain theories because no one has ever detected a single particle of dark matter. No detection, no direct measurement, no confirmed signal. The world's largest experiments, from underground bunkers and ultra-pure crystal detectors to the most powerful proton colliders, have all returned the same chilling result: absolute silence. Dark matter seems to deliberately evade every instrument humanity has ever built, as if guarding a secret deeper than we realize. From the absolute silence of every experiment, a bolder idea emerged. Dark matter may not simply be scattered particles drifting through space, but the faint signature of an entire dark universe existing right beside our own. In this hypothesis, that dark world possesses its own particles, its own forces, and even its own physical laws, rules that modern science has never encountered. It operates quietly, interwoven with our universe, yet barely interacting, allowing both realities to coexist without ever truly touching. If this is true, everything humanity observes is merely the visible tip of the iceberg, while the vast hidden portion belongs to a shadowy, mysterious, and fundamentally different realm, one we can detect only through the gravity it leaves behind. These unanswered questions push us towards something even more unsettling. What if dark matter is not any kind of matter we know? What if it is not a particle, not energy, not anything in the standard model? If so, it could mean that the entire theory of gravity used by humanity might be incomplete or even wrong. Perhaps Einstein's equations only apply to normal matter, while the majority of the universe, the 85% made of dark matter, operates under different rules. This idea doesn't just challenge our knowledge of physics, it challenges our understanding of reality itself. Some scientists have dared to go further, asking, what if dark matter does not exist at all? What if it is simply a sign that we misunderstand gravity? Alternative theories like MOND propose that gravity becomes stronger or behaves differently on large scales, making galaxies appear as if they contain invisible mass. If these ideas are true, humanity may be on the brink of the greatest scientific revolution since Newton and Einstein one, that rewrites our understanding of force, space, and time. So in the end, what exactly is dark matter? A completely new form of matter, an unrecognized type of energy, a non-interacting particle, a force from a parallel universe, or a monumental error in the physical theories we consider foundational? To this day, no one knows, and it is precisely this not knowing that gives the mystery its immense power. When we look at the night sky, the shimmering stars are nothing more than tiny specks floating in an ocean of invisible matter, an ocean that holds galaxies together, shapes the fate of the universe, and may determine the future of human physics. Dark matter reminds us that the universe holds far more secrets than we can comprehend, and sometimes the things we cannot see are the ones that control everything. Among countless stories about the origin of the solar system, one hypothesis has shaken the entire scientific community. Did we once have a twin planet, a second Earth, orbiting the sun alongside us, only to disappear without leaving a trace? It sounds like the opening of a science fiction film, but astronomical observations, geochemical evidence, and orbital simulations all suggest this idea may be far more realistic than we imagine. Looking back at 4.6 billion years of chaos, every planet carries scars from catastrophic impacts, and in the middle of those fragments lies something that doesn't fit a strange gap. Many scientists believe could be the remains of a world that no longer exists, the planet Theia, or another sister planet that once shared Earth's orbit. What do you think happened to the second Earth? Share your thoughts in the comments below. The giant impact that formed the Moon has long been considered one of the events that defined Earth's destiny, yet hidden within it lies an even deeper mystery, the existence of another planet named Theia. According to the giant impact model, more than 4.6 billion years ago, the early Earth collided with a Mars-sized planet. The impact was so violent that it vaporized and ejected trillions of tons of material into orbit, creating a debris disk that gradually cooled and merged into the Moon we see today. But the strangest part of the story isn't the Moon, it's Theia itself. How could a planet large enough to create the Moon vanish, completely leaving no independent fragments anywhere in the solar system? The isotopic composition of lunar rocks is almost identical to Earth's, so similar that many geochemists suspect Theia may have shared an extremely Earth-like structure, allowing both worlds to blend entirely during the collision. This leads to a bold, yet increasingly convincing idea. Theia may have been the second Earth, a twin planet born alongside ours, but erased from history by a single irreversible cosmic impact. A bold hypothesis suggests that Theia was never as far from Earth as we once believed. Instead of wandering somewhere in the solar system, Theia may have quietly shared the same orbit as Earth from the very beginning, hiding at the L4 or L5 Lagrange points, gravitationally stable regions where a smaller planet could remain for millions of years without drifting away. In orbital dynamics simulations, two Earth-sized planets can indeed circle the Sun like synchronized dancers, moving in harmony without ever colliding. Yet just a slight disturbance shifting gas in the protoplanetary disk, an impact from a third body, or gravitational oscillations from Jupiter would be enough to destabilize Theia. After that, it would slowly drift out of its safe zone slip into a converging trajectory and begin approaching Earth, setting the stage for the fateful collision. If this hypothesis is true, Theia was not a distant stranger, but Earth's twin ghost, orbiting silently beside us, hidden in perfect balance until destiny forced the two worlds to merge into one. Yet the strangest clues lie deep beneath Earth's surface. Recent geochemical and seismic studies have revealed mysterious regions within the deep mantle known as LLSVPs, large low-shear velocity provinces. Their isotopic composition does not match the rest of Earth, almost as if the material originated from another planet. Many scientists believe these may be remnants of Theia that never fully mixed with Earth, buried 3,000 kilometers below the crust. If true Theia did not completely vanish, part of it still resides inside Earth itself, like a foreign heart imprisoned within our planet. But the greatest and most haunting mystery, the reason this topic is called the second Earth, lies in the final dangerous question: if a second Earth once existed, where did it go? The first and perhaps the most terrifying possibility is that the second Earth was completely destroyed in the collision. If this happened, an entire world that may have once had oceans, volcanoes, and atmosphere, and even the earliest seeds of life, would have been erased within just a few hours. The immense energy of the impact would have melted the entire planet into plasma, pulling most of its material into Earth, while the rest dispersed into space as scorching dust, leaving no identifiable fragments behind. The chilling truth is this: if a Mars-sized planet can be wiped out by a single impact, then such a fate could befall any world, and Earth is no exception. The second possibility suggests that the second Earth was not destroyed at all, but instead ejected from the solar system after an off-center collision. When a planet is struck at an uneven angle, Its orbit can be distorted so severely that it loses all gravitational connection to the Sun. At that moment, it would be thrown into the cold, dark void between the stars, becoming a rogue planet, a world without sunlight, without energy, drifting silently through the darkness for hundreds of millions of years. If Theia did not slam directly into Earth, but was instead flung outward, then, somewhere in the deep expanse of space, there could still exist a frozen, dead planet carrying the remnants of a history erased from the solar system. What makes this idea even more compelling is that astronomers have already discovered countless rogue planets throughout the galaxy, meaning the solar system ejecting one of its own is far from impossible. In fact, it would be stranger if such a planet had never existed at all. The third possibility, and the one that sends the strongest chill through the scientific community, proposes that the second Earth is still inside our solar system, and we simply haven't seen it yet. Several orbital simulations suggest that if a Mars-sized planet existed on an extremely steep, distant, and elongated orbit, it could easily evade every telescope for centuries. Imagine a planet moving so slowly that it takes tens of thousands of years to complete a single orbit around the Sun at such vast distances, its reflected light would be nearly zero, turning it into a drifting mobile shadow at the edge of the solar system. Much like the hypothesis surrounding Planet 9, this hidden world could be lurking in regions of space we have barely surveyed, where even small objects are difficult to detect, let alone a true planet. If this is true, then within the very same solar system, we may be living beside a forgotten twin world, a planet that should have been our second Earth, now buried in darkness, silently drifting through cosmic time. Some scientists even propose that life on Earth may have originated from that sister planet. If Theia had oceans and extremely primitive life, the impact could have seeded early Earth with biological material. This would make the second Earth not just a lost planet, but the first cradle of life, a place we will never witness crushed billions of years ago. All these stories point toward one thing in the distant past: Earth may not have been as alone as we think. A sister planet may have existed similar to ours, orbiting the Sun, possibly with mountains, oceans, and a blue sky. But it vanished in the chaos of the early solar system, leaving behind a question that still haunts modern science. If there truly was a second Earth, where did it go? And will we ever find its final trace in this vast universe? In the vast darkness of our solar system, there is one planet that makes scientists both fearful and fascinated. A colossal gas giant, where crimson storms rage for centuries, where gravity is strong enough to bend the fate of entire worlds around it. Jupiter, a planet that has saved us yet, could destroy us in an instant. And the most haunting question in modern astronomy is this giant silently protecting Earth? Or is it merely a cosmic beast acting on instinct, indifferent to the existence of humankind? What do you think is Jupiter? A protector or a destroyer? Share your thoughts in the comments below. When we observe Jupiter, the gas giant, with a mass more than 300 times that of Earth, we see a chaotic world where swirling storms last for centuries and cloud bands twist like cosmic serpents in endless motion. Yet beneath this beauty lies a gravity so powerful it can bend the orbits of any celestial object that drifts too close. This immense gravitational force creates Jupiter's frightening dual nature. It can pull everything into its depths, but it can also fling objects back into space like a cosmic slingshot. And it is precisely this contradiction that makes the question predator or protector one of the most challenging mysteries in modern astronomy. To many scientists, Jupiter is like a massive cosmic shield, silently standing between Earth and the dangers hurtling in from the depths of space. Computer simulations show that if Jupiter were removed from the solar system, the number of asteroid impacts on Earth wouldn't just double, it could increase by tens or even hundreds of times. This proves that its protective role is not an exaggeration, but a serious scientific reality. The clearest evidence is the Shoemaker-Levy 9 event in 1994. Instead of heading toward the inner planets, a giant comet was pulled in by Jupiter's gravity, shattered into more than 20 fragments, and exploded in its atmosphere with the force of millions of megatons. The explosions were larger than Earth itself, leaving enormous dark scars that lingered for months. Had Jupiter not taken the hit, it is difficult to imagine what might have happened to our planet. Because of events like this, many researchers believe Jupiter has effectively extended Earth's lifespan, dramatically reducing the number of catastrophic impacts, and in doing so, giving life the chance to form and evolve over billions of years. However, the situation is not that simple. Other models show that Jupiter doesn't only pull objects in, it also pushes them. As it orbits the Sun with immense gravitational force, it warps surrounding space and creates a cosmic slingshot effect, flinging asteroids from the asteroid belt toward Earth. In other words, the protector sometimes becomes the source of danger. When looking back into the early history of the solar system, Jupiter no longer appears as a protector, but emerges as a true planet killer. According to the Grand Tack hypothesis, one of the most widely discussed models in modern astronomy, Jupiter once migrated deep into the inner region of the solar system, acting like a colossal wrecking ball, sweeping through the area where the first rocky planets were struggling to form. Its gravitational force was powerful enough to tear apart young celestial bodies, crushing potential super-Earths, large planets that may once have possessed environments suitable for life. Smaller planetary embryos were pulled inward and destroyed, while larger bodies were hurled off their orbits, drifting into the cold, dark void of deep space. Even more frightening is that Jupiter did not simply charge inward as a destroyer. Simulations suggest it suddenly reversed course, migrating outward again and leaving behind a chaotic battlefield of shattered rock and planetary remnants. Yet this devastation created the empty space necessary for Earth to form later. In other words, for us to exist today, entire worlds may have had to die. Worlds that Jupiter erased in the earliest dawn of the solar system. A bittersweet paradox emerges: without Jupiter, Earth might never have existed. But also, without Jupiter, perhaps a larger, more stable, more habitable Earth-like planet could have formed, only to be destroyed before its time. Did Jupiter create us, or did it kill the siblings we never met? The most important question, and the greatest mystery in this entire story, is the role Jupiter will play in humanity's future. This is where modern science becomes humble, because even the most advanced supercomputer simulations, from NASA to the ESA, produce contradictory results. Some models indicate that Jupiter will continue to carry the burden, shielding Earth from the majority of cosmic threats and reducing asteroid impact risks by up to 90%. But others reveal a darker possibility. Jupiter's immense gravity also creates resonance zones within the asteroid belt regions, where even a tiny disturbance can knock massive rocks out of their stable orbits and send them hurtling toward Earth. In other words, the same planet governed by the same physical laws may either safeguard us or mark the end of life as we know it. This raises a haunting question: is Jupiter a finely tuned, balancing component of the solar system, so precise that if it were just slightly larger or smaller, the entire planetary system would collapse? Or are we simply living during a lucky moment in cosmic history, a brief era where Jupiter happens to act as our protector before shifting into an entirely different role? And if that shift ever comes, will we even realize it before it's too late? In reality, the orbits of asteroids are far less stable than we imagine. Every few thousand to 10,000 years, Jupiter's immense gravity subtly disturbs their paths, creating tiny but dangerous deviations. Just a shift of a few hundred meters is enough to redirect a massive rock tens of kilometers wide toward Earth. This makes many scientists shudder and wonder, is humanity's fate truly dependent on the mood of a giant planet hundreds of millions of kilometers away. We cannot control it, we cannot predict its long-term effects, and we cannot know whether this planet is on our side or simply following the harsh, indifferent laws of physics. Thus, the greatest mystery is not what Jupiter did in the past, but the question facing us today: is Jupiter safeguarding humanity's future, or simply waiting for the moment to become the greatest destroyer Earth has ever faced? And that is the question that sends chills down the spine of every scientist, because no one can say for sure which answer is true. In the infinite cosmos, where light takes millions of years to reach human eyes, exists a group of objects rarely mentioned but carrying power that surpasses every boundary of physics: magnetars, neutron stars with the strongest magnetic fields known in the universe. When a massive star ends its life in a supernova explosion, its core can collapse into an object only a few dozen kilometers wide. But instead of becoming an ordinary neutron star, a small fraction of them, for reasons science still cannot fully explain, transform into magnetic monsters possessing power capable of bending space and altering the structure of matter at the atomic level. Magnetars demonstrate that the universe still hides dark corners full of mysteries, where even the familiar laws of physics begin to break down. What do you think causes some neutron stars to transform into the most powerful magnetic monsters in the universe? Share your thoughts in the comments below. A magnetar's magnetic field exceeds anything humans have ever imagined. If Earth's magnetic field can guide compasses and shield us from solar radiation, then a magnetar's magnetic field is 1,000 billion times stronger. This number renders all measurement instruments meaningless. At distances of tens of millions of kilometers, it can already disrupt electronic devices. At closer ranges, its field is strong enough to stretch electrons out of their atomic orbits, deforming atoms like elongated strands. This is a region where ordinary matter no longer behaves the way we understand it. A living organism approaching a magnetar would be destroyed at the atomic level before realizing what was happening. In other words, the magnetar is the ultimate symbol of absolute power, a place where the physics of Earth loses its meaning. Even stranger is the explosive energy magnetars can unleash. They frequently produce bursts of X-rays and gamma rays so intense they shock the scientific community. A single burst lasting a fraction of a millisecond can release as much energy as the Sun emits in hundreds of thousands of years. When the magnetar SGR 180620 erupted in 2004, although it was nearly 50,000 light-years away, it still saturated observation satellites and disrupted radiation measurement systems. If such an event occurred within a few dozen light-years, Earth could face devastating consequences. It is a reminder that in our vast universe, there are forces far beyond anything humanity can withstand. Inside a magnetar lies a realm completely alien to every physical concept humans have ever known. Here, matter is compressed to unimaginable densities. Just 1 teaspoon of magnetar material can weigh as much as an entire mountain on Earth. The overwhelming pressure forces protons and electrons to merge, forming a dense ocean of neutrons where particles no longer maintain their familiar structure. The crust of a magnetar is so compact that it can vibrate like metal under extreme tension, and even a tiny oscillation can release enormous amounts of energy. Its surface temperature reaches tens of millions of degrees Celsius, yet the radiation emitted is primarily in the X-ray range, too intense to appear in the visible spectrum. All of this reveals that a magnetar operates in conditions so extreme they challenge every modern physical model we possess. A magnetar is a paradox of the universe. It exists for an extremely short period, yet leaves an imprint far greater than its lifetime. Compared to stars that can live for billions of years, a magnetar lasts only around 10,000 years, barely a flicker on the astronomical timescale. Its colossal magnetic field decays rapidly. As time passes, the magnetic structure gradually weakens and the magnetar transitions into a normal neutron star. This burning in a single flash lifespan makes them incredibly rare. Perhaps only a few dozen exist in a galaxy of hundreds of billions of stars. They are like explosive offspring of supernovae born from chaos, shining with unimaginable power and vanishing before the universe can fully record their story. Among all the bizarre traits magnetars possess, from their surreal matter density to gamma-ray eruptions powerful enough to disrupt entire galaxies, nothing confuses scientists more than the question, where does that colossal magnetic field come from? This is not just a simple mystery, it is a doorway leading to the ultimate boundaries of physics. Even though we have studied neutron stars for decades, magnetars still break every model, every equation, and even every scientific intuition humanity has ever built. The first and oldest hypothesis suggests that magnetars are born with supercharged rotational speeds. When the core of the progenitor star collapses, it may spin fast enough to complete a full rotation in just a few milliseconds. This frantic rotation, combined with flows of charged plasma, could create a dynamo effect, far stronger than any magnetic field that has ever existed. But a major problem arises. Many observed magnetars do not rotate anywhere near the speed the model requires. Some even rotate unusually slowly. The contradiction between theory and observation keeps this hypothesis from standing firmly. The second hypothesis takes the story to a more dramatic level too. Neutron stars collide, mixing their magnetic fields and creating a new magnetar with strength far surpassing the sum of both initial stars. While the idea sounds plausible, such collisions typically form black holes, not magnetars. So why do a few rare cases survive and become the most magnetic objects in the universe? No one has an answer, and this inconsistency continues to puzzle astrophysicists. A third hypothesis, bold and mysterious, focuses on the deep internal structure of magnetars. Some scientists believe that under extreme pressure, neutrons may arrange themselves into exotic forms of supermatter, such as neutron crystal phases, quark liquid, or even states of matter that have never been observed. These structures, if real, could generate electromagnetic effects far beyond anything humans can simulate. However, because no technology exists to observe the interior of a neutron star directly, this idea remains suspended between science and speculation. What deepens the mystery even further is the absolute magnitude of the magnetic field. No model in modern physics predicts magnetic forces reaching trillions of Gauss, millions of times stronger than anything created on Earth. A magnetar's magnetic field behaves like a natural amplifier built by the universe through a mechanism no one understands. Some physicists even believe magnetars might be revealing cracks in classical electromagnetic theory, forcing us to expand our understanding into quantum physics under extreme conditions. Magnetars, therefore, are not just powerful objects. They are milestones reminding us that the universe still hides layers of secrets yet to be uncovered. Each magnetar acts like a natural laboratory where time, space, and matter are stretched to their limits. And within those limits, the secret of their colossal magnetic fields continues to hide, silently resisting every attempt at scientific explanation. If we ever discover the true answer, it may reshape all of modern physics, from the nature of fundamental forces in the universe to our understanding of the death and rebirth of stars. For now, magnetars remain silent and solitary in the darkness of space, standing like monuments to the unknown, both frightening and mesmerizing. There is an invisible force quietly dragging the entire Milky Way through the darkness, and we cannot see it at all. No light, no signal, no clue. Only one thing is certain. Every galaxy around us, tens of thousands of them, is rushing toward the same direction, as if pulled by a colossal power hiding at the edge of the universe. That motion reaches 2 million kilometers per hour, a speed far beyond anything we normally associate with galactic movement. Yet when telescopes point toward that destination, all they reveal is nothing. Absolute emptiness. No light, no radiation, no sign of matter. Only one remaining trace. The surrounding space is being warped by an immense gravitational force strong enough to bend the motion of the entire Laniakea supercluster. This mystery has turned the Great Attractor into one of the greatest cosmic riddles of our era, a gravitational phantom manipulating the entire cosmic home of humanity without ever revealing its identity. What do you think is really hiding behind this invisible force, and why do you believe it has remained undetectable for so long? Share your thoughts below. The Great Attractor lies entirely within a special region of the sky known as the Zone of Avoidance, where telescopes are almost powerless. In this area, cosmic dust, hydrogen gas, and dense star fields from the Milky Way itself form a wall that blocks nearly all light coming from behind it. Paradoxically, we can observe galaxy clusters billions of light years away, yet we cannot see through a region only a few 100 million light years distant because the veil of our own galaxy is too dense. This forced blindness makes the Great Attractor even more mysterious. If it were a massive galaxy cluster, its light should still slip through in other wavelengths such as infrared or gamma rays, but every wavelength remains silent. No light, no radiation, no signal. An absolute void to our instruments, even though its gravity is powerful enough to distort the motion of an entire supercluster. The greatest mystery of the Great Attractor does not lie in its strength, but in its absolute silence. Even though it is powerful enough to distort the paths of tens of thousands of galaxies, it remains completely invisible to every type of telescope humanity possesses. No light emerges from that region of space, no radio waves, no X-rays, no signs of hot gas, nor any form of detectable radiation. This makes it unlike any galaxy, unlike any star cluster, unlike any familiar cosmic structure. All that scientists can observe is an anomalous gravitational effect, no shape, no boundary, no measurable density. Its existence is inferred solely from the way it bends the motion of the surrounding space, as if a colossal entity were hiding in the darkness, stretching out an invisible hand to pull the entire Laniakea supercluster closer. This state of absolute invisibility has led many to question whether the Great Attractor is truly a physical object at all, or merely the manifestation of something deeper and more fundamental within the fabric of the universe, a gap in humanity's understanding of space-time itself. Although many hypotheses have been proposed to explain the nature of the Great Attractor, none of them are truly satisfying. Some researchers suggest it might be a collapsing supercluster, but such an enormous structure should emit strong light, revealing signs of hot gas, cosmic dust, and radiation from stars. Yet the region is completely dark, causing this hypothesis to be questioned almost immediately. Other scientists turn to dark matter, the invisible substance that makes up most of the universe's mass. Dark matter emits no light and no signals, but still generates gravitational pull, making it a plausible candidate. However, to produce a force strong enough to distort the motion of an entire region as vast as Laniakea, the dark matter density would need to be extraordinarily high, far beyond any known model. This makes the hypothesis still unconvincing. Some even propose bold ideas that the Great Attractor could be a remnant of the universe's rapid inflation after the Big Bang, or the boundary of a cosmic bubble where space-time density shifts abruptly. But all of these remain speculative, lacking any observational evidence. The more hypotheses appear, the deeper the mystery grows, and the Great Attractor continues to defy every model humanity has built to understand the cosmos. The most surprising discovery came when scientists looked deeper and found that behind the Great Attractor lies an even more massive structure, the Shapley supercluster. With its dense concentration of galaxies and overwhelming mass, Shapley may exert a gravitational pull even stronger than the Great Attractor. Some astronomers believe that the Milky Way's motion is actually the result of both forces combined, as if we are being pulled by multiple gravitational giants at the same time. However, others argue that Shapley is the true dominant source and the Great Attractor is merely an intermediate effect. This disagreement makes the overall picture even more ambiguous, suggesting that there may be even larger cosmic structures hidden beyond our current view. This deepens the mystery and dread surrounding the Great Attractor. It is like drifting in a powerful current, knowing there is a waterfall ahead, pulling you in, yet being unable to see where it is, how big it is, or how many levels it has. The only certainty is that the Milky Way, the home of humanity, is on an unstoppable journey. And although this motion spans hundreds of millions of years, the idea of an invisible cosmic hand dragging us forward still sends chills down many spines. The greatest mystery of the Great Attractor lies here. It is dark, silent, structureless, yet powerful enough to pull our entire galaxy without leaving any trace in the ways ordinary matter does. In a universe where nearly everything we discover relies on light or radiation, signals the existence of a massive gravitational region that is completely invisible is extremely difficult to accept. It challenges the foundations of modern physics. It forces scientists to consider bold, risky theories that could shake the very pillars of our understanding of the universe. That is why the Great Attractor is not just an astronomical mystery, it is one of the deepest, most profound questions about the true nature of reality. Is what we see with our eyes and telescopes only a tiny portion of a much larger existence, one governed by invisible forces shaping space-time in ways humans still cannot comprehend? And if we are being pulled towards something completely invisible with no light, no signal, no structure, what exactly awaits us at the end of that path? Among all the strange, frightening, and imagination-defying things the universe has ever produced, perhaps nothing feels more illogical to humanity than the existence of ultramassive black holes, colossal black holes whose size far exceeds every limit science currently considers reasonable. They are not just hundreds of times larger than ordinary supermassive black holes. They reach masses of tens or even hundreds of billions of suns, a number so extreme that even the most established cosmological models fall silent. To astronomers, these monsters resemble gigantic shadows born from the darkest corners of the early universe, appearing too early, too large, and too mysteriously, so much so that all current explanations feel like temporary patches on a problem far bigger than we can grasp. What do you think could be the reason these black holes are so absurdly large? Share your thoughts in the comments below. When it comes to ultramassive black holes, the most astonishing aspect for scientists is their size completely defies every rule of stellar formation. Some of these black holes have event horizons so vast that they exceed the orbit of Neptune, meaning their no-escape zone alone is as large as the entire solar system. This is something no black hole born from the death of a star could ever achieve, because no star in the universe is massive enough to leave behind such an enormous remnant. This forces scientists to confront two paradoxical possibilities. Either these black holes spent billions of years growing continuously, or they were born already monstrously large. And ironically, both scenarios conflict directly with the timeline of cosmic structure formation, making the origin of their immense size one of the most troubling mysteries in modern cosmology. The most baffling part is that many ultramassive black holes have been discovered in the universe when it was only a few 100 million years old, far too early for such giants to form if they grew at normal rates. They appeared during an era when galaxies had not yet stabilized, when matter was still chaotic and stretched by the initial expansion of space-time. How could these black holes grow so rapidly in such a short cosmic window? This question stands as one of the greatest paradoxes in modern cosmology. Another strange fact is the overwhelming energy they release when feeding. The accretion flows near their event horizons produce quasars so bright that they can outshine hundreds of thousands of galaxies combined. Their relativistic jets, narrow beams of matter, moving at near light speed, can sweep away gas across entire galaxies, shutting down star formation for hundreds of millions of years. In other words, the existence of ultra-massive black holes is not just a physical oddity, it is a force capable of dictating the destiny of entire galaxies. What makes them true lords of cosmic darkness lies deeper. No one knows how they formed. Classic theories suggest black holes grow by slowly consuming matter or merging with other black holes. But even with continuous mergers and persistent feeding, the end result should be supermassive black holes, not ultramassive ones. To reach dozens or hundreds of billions of solar masses in a cosmic moment, just after the Big Bang, they must have grown through a completely different mechanism. Some scientists believe that ultramassive black holes may originate from primordial black holes, objects that formed in the very first moments after the Big Bang, when matter was so dense that spacetime compressed, and quantum fluctuations could collapse directly into black holes. If this occurred, they might have been born already enormous without needing the long growth process typical of ordinary black holes. However, to this day, science has found no direct evidence proving the existence of these ancient cosmic seeds, leaving the hypothesis both promising and deeply mysterious. Another hypothesis suggests that ultramassive black holes may have formed from gigantic primordial gas clouds in the early universe. These were so dense that their entire structure could collapse directly into a black hole without breaking into thousands of smaller stars. However, for such a massive cloud to avoid fragmentation, it would need to exist under extremely rare conditions. Temperature, pressure, and density all perfectly balanced at a level that is almost impossible to reproduce. And even if this scenario did occur, it still fails to fully explain why some ultramassive black holes have reached the absurd and overwhelming sizes we observe today. A possibility that modern science hesitates to accept, but cannot dismiss, is that our current physical models are incomplete. The early universe may have operated under rules we have not yet discovered. Black holes may have grown at rates far beyond the Eddington limit. Or perhaps unknown forms of matter or energy acted as superfuel, enabling explosive growth far faster than standard physics allows. All attempts at explanation lead scientists into a dead end, which only deepens the dark allure of ultramassive black holes. They may be the key to unlocking the next chapter of our understanding of the universe. When an object follows none of the rules, we know there are only two possibilities: the object is unusual, or our rules are incomplete. This is the central point, the greatest mystery, the deepest cosmic question. Why are they so impossibly large? Not just unexpectedly large, not just larger than predicted, but large enough to challenge the entire foundation of modern cosmology. If they were born too early, grew too fast, and reached such monstrous sizes, something in the early universe must have operated very differently from what our models predict. Perhaps unknown physical mechanisms, unrecognized states of matter, or even ancient pre-matter energy fluctuations served as cosmic reactors that forged these beasts. Or a more unsettling possibility, their existence may be proof that the universe is far less simple than humans believe. Ultramassive black holes may not be rare anomalies, but relics of a chaotic, compressed and unimaginable era of the cosmos. They might be colossal tombstones, marking vanished physical processes, or ancient energy fields we have never encountered. In other words, Ultramassive black holes are not just abnormally large black holes, they are reminders that most of the universe remains beyond our comprehension. They challenge the entire foundation of modern physics and force us to ask whether the cosmos hides secret rules we have yet to decode. Until we uncover the answer to the ultimate question, why are they so impossibly large? Ultra-massive black holes will remain one of the darkest, most perplexing, and most mesmerizing mysteries in the universe. For as long as humanity has looked up, Saturn's rings have seemed eternal, a shimmering cosmic halo, delicate yet impossibly grand, drifting in silence at the edge of our skies. They look timeless, unchanging, almost sacred. But that illusion is breaking. Behind their beauty lies a secret the universe has been hiding in plain sight. Saturn's rings are dying right now. Not over billions of years, not at a pace beyond imagination, but within a window of time, so brief that humanity has appeared at the exact moment to witness their final act. What we once believed to be an immortal symbol of the solar system is quietly collapsing, grain by grain, in a celestial rain that no human eye can see. What do you think will happen to Saturn once its rings disappear completely? Share your thoughts in the comments below. The phenomenon known as ring rain is the strongest evidence that the lifespan of these icy rings is counting down. Instead of remaining stable and enduring around the planet, the tiny ice particles that form the rings are continuously pulled downward by Saturn's gravity and magnetic field, plunging into the atmosphere and dissolving into its thick cloud layers. It is a silent, invisible process, yet fierce and relentless, like a massive hourglass pouring out its last grains of sand. The water ice and dust particles within the rings become ionized, sliding along magnetic field lines and falling like an electric rain. NASA describes them invisible showers that cannot be seen with the naked eye, but can be detected through chemical changes in the atmosphere. By analyzing light spectra and ion density, scientists discovered that the amount of material falling from the rings is far greater than previous models suggested. And this marks the beginning of new mysteries. The rings are disappearing at a rate so high that many long-standing theories must be rewritten. Using data from the Cassini spacecraft, scientists estimate that thousands of kilograms of ring material fall towards Saturn every second. To visualize it, the amount of water raining down each day is enough to fill an Olympic-sized swimming pool within just a few minutes. This unveils a harsh truth. Saturn's magnificent rings are not only young, but they are aging far more rapidly than expected, potentially disappearing completely within a few tens to 100 million years. On the scale of cosmic time, that is merely a blink of an eye. But the bigger question is, why are Saturn's rings unexpectedly young? This is one of the most debated mysteries in planetary science. For decades, scientists believed the rings formed alongside Saturn more than 4 billion years ago. Yet the purity of their ice contradicts that idea completely. If the rings had existed since the solar system's beginning, their particles would be darkened by cosmic dust and meteor fragments, giving the rings a visibly dim gray tone. Instead, they remain almost perfectly bright and white, as if created only recently on a cosmic timescale. This has led many researchers to suspect that the rings may be the remnants of a young icy moon, torn apart by tidal forces, or the aftermath of a colossal collision that shattered a larger celestial body, leaving behind a vast field of debris orbiting the planet. Cassini's data also revealed strange chemical signatures in Saturn's atmosphere, chemical fingerprints indicating the constant rainfall of ring material. Hydrogen ion concentrations fluctuate, polar brightness changes with the seasons, and ionization levels vary according to mysterious cycles still not understood. This suggests that the interactions between the rings and the planet are not merely physical processes, but a complex chain of reactions where the ring's erosion actively influences the planet's atmosphere. Even more puzzling, the rate of ring rain is not stable. At times it surges dramatically, then suddenly decreases. These fluctuations occur with seasons, with the tilt of Saturn's axis, and sometimes follow no recognizable pattern at all. Each irregular change forces scientists to reconsider the existing models of ring behavior. This raises a broader question: were the rings once far thicker in the past and are now in their final stage of decay? Or did they form relatively recently and are being eroded rapidly due to unforeseen magnetic interaction? However, the greatest and most important mystery, the one that has kept countless astronomers awake at night, is the question: how fast are Saturn's rings dying? This is not just a matter of time, but of understanding the fundamental nature of their destruction. If the current rate of ring rain remains stable, the rings may survive for a few 100 million more years long for humanity, but short for the lifespan of a planet. But if the rate is increasing, as some fluctuating data suggests, we may be witnessing the final chapter of a cosmic icon. Some scientists even propose that the rings were much thicker in the recent past, and that ring rain is pushing them into a state of accelerated collapse. The more material they lose, the weaker their structure becomes, and the weaker they become, the faster they erode, a self-reinforcing cycle of destruction like a storm consuming itself. More concerning still, no one knows whether this process can reverse. Could the rings be replenished by meteor impacts? Could one of Saturn's moons be torn apart, in the future forming a new ring system? Or is this truly the last chapter in the ring's history, and once they vanish, Saturn will stand bare, with only its pale, cloud-covered surface like any other gas giant? The question, how fast are Saturn's rings dying, also carries a deeper meaning. It measures humanity's understanding of this planet. Cassini, the only spacecraft ever to dive between Saturn and its rings, sent back priceless data before plunging into the atmosphere and disintegrating in 2017. But that data is still not enough. We lack a complete model of the electric currents, magnetic fields, particle densities, and the interaction between solar radiation and ring material. In other words, the death rate of the rings is the ultimate test of modern planetary science. And ironically, even as they die, Saturn's rings make the planet more vibrant than ever. They reflect sunlight-shaped atmospheric behavior, create unique optical effects, mark seasonal changes at the poles, and serve as an ancient record of moon dynamics and past collisions. Yet all of this beauty is slipping away grain by grain. The most humbling realization is that humanity exists during a tiny, fleeting moment in cosmic history, the exact moment when Saturn's rings are at their brightest and most spectacular. Had humanity appeared a few 100 million years earlier or later, we might never have known that Saturn once wore such a divine halo. And perhaps it is their fragility that makes them even more beautiful, the beauty of something that is about to disappear. Because every wonder, whether of Earth or the universe, becomes most precious in the final moments before it is gone.